We're going to start this out doing a little bit of review. Working with rational expressions that involve variables, you're going to use the same rules as when you multiplied and divided fractions. So I'm going to review that with you first and then move into rational expressions. If I have two fractions that are multiplied together, the first thing that I'm going to do, it might be tempting to just multiply straight across and then simplify, but it's a lot easier to simplify before you do the multiplication. So if I'm going to do that, when I simplify two fractions, I simplify either from a numerator and denominator that are above each other, or from a numerator and a denominator that are across from each other. This is not the same thing as cross multiplication. Cross multiplication happens when we have an equal in the middle. This is a multiplication sign. This is completely different than cross multiplication. This is where I simplify by doing it crossways. So I'm going to simplify. 2 goes into 20 10 times. So I've got a 10 left over. 2 goes into 2 once. So those are both divisible by 2. Here, the 15 and the 3 are both divisible by 3. So that's going to be a 1. That's going to be a 5. And then 1 over 1, that is simplified as much as I can get it. And then the 5 over 10, well, that simplifies to a 1 over 2. So now if I multiply straight across, 1 times 1 is 1, 1 times 2 is 2. My answer there is 1/2. You could have multiplied straight across. 2 times 15 is 30 and 3 times 20 is 60. But sometimes the numbers you get there are pretty difficult. So it's a lot easier to cancel out crossways first and then do your multiplication. And that becomes really evident when you're dealing with variables within your equations, because if you don't simplify first, they can get pretty difficult sometimes, especially when you're dealing with trinomials. So let's simplify first diagonally and up and down, and then we'll multiply what we have left over. So here, 8 and 16, 8 goes into both of those. 8 would be a 1, 16 would be a 2. And here, 5 goes into 10 twice, so I have a 2 left over. The 5 cancels out to a 1. And here I've got 5 x's and 3 x's, so the 3 x's cancel completely. These 5 x's become x squared. And then if I look up and down, 1 and 1x squared does not simplify, but 2 and 2, they do simplify to a 1. So those 2's both cancel out to give me 1 over 1. So when I multiply straight across, my answer here is 1 over 1x squared, or just 1 over x squared to simplify. For the next one, for this one, it's a division problem. The difference between multiplication and division is when we have a division of fractions, we always keep the first fraction the same. We change the division to multiplication, and then we flip the second fraction upside down. So we make it its reciprocal. So that's 35 over 20. At this point, it is a multiplication problem, so we just simplify like normal. So 2 goes into 20 10 times, 2 becomes a 1. 5 goes into 35 7 times, the 5 becomes a 1. And then the 7 and 10 do not simplify, so 1 times 7 is 7, 1 times 10 is 10, and that is in simplified form. If we multiply straight across and we still get something that will simplify, it's okay to simplify at this point. For this one, it's a division of fractions, so I'm going to keep the first fraction the same, change the division to multiplication, and flip the second fraction to its reciprocal. Then I'm going to simplify diagonally. So 14 and 7, 7 goes into both of those. 7 will be 1, 14 will be a 2. Here your x's cancel out. 2 goes into both those numbers. This becomes a 1, this becomes a 4. And then here your 4 and 2 cancel. The 2 becomes a 1, 4 becomes a 2. And then we multiply straight across. So 2 times 1 is 2. And 1 times 1 is 1. All the x's canceled out, so that one just simplifies to a simple 2. You do not need the 2 over 1. Since it's a whole number, no need to put that 1. It's in simplified form as 2. Here's another way to write a division problem of fractions. That means the same thing as 2x squared over 5 divided by 10 over 5x cubed. So when I rewrite it, I'm going to rewrite the top, 2x squared over 5, and I'm going to invert this one when I multiply. So I'm going to say times, the bottom or the denominator becomes the new numerator, 5x cubed over 10. And at this point it's a multiplication, so I can simplify. 5 goes into 5, they both end up being 1. 2 goes into 10, 2 is a 1. 10 becomes a 5, and then we multiply straight across. X squared times x cubed is x to the 5th. Remember, when we have two monomials multiplied together, we keep the base and add the exponents. And then that would be over 5 to give us our final answer. For this one, you can treat the 5 as a fraction, as 5 over 1. So at this point, it doesn't look like anything cancels out diagonally. I can't cancel the x's because this x is attached to the one with an addition, so I just multiply straight across. That would give me a 15x over 1 times x plus 1 is x plus 1, and that's all I can do with that one. There's nothing there that will simplify. For this one, I'm going to rewrite it. I keep the first fraction the same. The top fraction is x minus 1 over x times, and I invert this and multiply, so that's 2 over 1. Nothing cancels here. This x is attached with subtraction, so I can't simplify the x's. It doesn't look like anything simplifies diagonally, so I will just multiply straight across. X minus 1 times 2, I distribute. That's 2x minus 2. And then x times 1 is just x. That's all I can do with that one. For this one, it's multiplication. I'm going to see if I can simplify anything. Here I could take out a 2. That will leave me with an x minus 5. So that doesn't really cancel with anything. So I think it's just going to be just as easy to just multiply straight across. So negative 1 times 2x minus 10 would be a negative 2x plus 10 over 15x. And that's really all I can do. Other than taking out a 2, there's nothing else I can do. And even taking the 2 out, nothing will simplify. So there's nothing left to do there. For this one, I'm going to rewrite it. Now, when you have something that can be factored, a lot of times you're going to want to factor that because you will be able to cancel entire factors from each other. So the x squared minus 9, when I rewrite that, I'm going to write that as x plus 3 times x minus 3. By now, you should be very familiar with recognizing difference of squares. We've done it so much. That's over 4. And then I multiply by the denominator inverted, or the multiplicative inverse, or the reciprocal of the denominator. So that would be an 8 over 3 minus x. Now, this becomes a little bit tricky here. X minus 3 and 3 minus x, they are not the same thing. But it's tempting to just cancel them out. They are very similar in that if I take a negative out of this 3 minus x, if you think about what would happen there, I'm just going to rewrite it. Now, you won't always have to rewrite, but just for the purpose of learning this new thing here, we've got x plus 3 times x minus 3, and that's all over 4. And then here, I'm going to bring a negative 1 out of that 3 minus x. If I take a negative 1 out, wouldn't that leave me with negative 3 plus x? And if you think about what negative 3 plus x is, isn't that the same thing as x minus 3 because of the commutative property? That's one of the reasons we learned properties earlier in this year, is so that you understand when you have one of the properties and you can use them within one of your operations. So here, this is the same thing as x minus 3. So this x minus 3 and this x minus 3 can now cancel, because we've forced them to be the same. We didn't change its value, we just made it look different by bringing out that negative 1. And then the 4 and the 8 will cancel. 4 becomes a 1, 8 becomes a 2. And then all I have left is the 2 times x plus 3. So that would be 2x plus 6. And then that negative is on the bottom. So that's over negative 1. But instead of doing that, I'm going to write it as negative 2x plus 6, or I could accept it as 2x or negative 2x minus 6. That would also work just fine. So they would accept, for something like this, the negative 1 times 2x plus 6 in parentheses. They would accept negative 2x minus 6, where you've distributed the negative 1. They would also accept a negative 2 times x minus 3. All three of those would be acceptable answers for this one. Looking at the next one, here we've got an 8 over 1. So I'm going to rewrite that as 8 over 1. Anytime you have a whole number, you can write it over 1 if you need a fraction. And I'm going to multiply that by the reciprocal. So that's 5x plus 1 over 2. And then the 8 and the 2 cancel. 8 becomes a 4, 2 becomes a 1. And we've simplified everything that we can. So now I'm going to multiply those together. So I could have 4 times 5x plus 1. That would be an acceptable answer. I could have 20x plus 4 also as an acceptable answer. Either one of those would be fine. Here is another example of multiplying rational expressions. And this is probably as difficult as they're going to get. In this, you have trinomials that have to be factored in order to simplify these. So the first thing that I would do in order to try to simplify is factor any trinomial that can be factored, or factor any difference of squares that can be factored. Anything that can be factored out needs to be done to see if you can simplify things or cancel things out. So that's what I'm going to do first. Here, are there factors of 8 that subtract to give you 2? Well, that would be 4 and 2. This is why we have done factoring so much this year. There are so many applications of it. And if you're not good at factoring, a lot of problems, especially as we move forward, are going to be very difficult to handle. So 4 and 2 subtract to give me a 2. The signs are different. The plus goes with the 4. So I have a plus 4 and a minus 2. On the bottom, factors of 3 that add to give me 4, that would be 1 and 3. The plus tells me they are both pluses, so that's factored. Here, I can bring out a 3. Now, if that had been a division symbol, I would have flipped the fraction, but this is multiplication, so I leave the fraction the same. I'm going to bring out a 3. That leaves me with an x plus 1, and then the x minus 2 does not factor. Now I'm going to try to cancel factors diagonally or up and down. As long as I'm canceling from a numerator and a denominator, I'm allowed to do it. And remember, I'm only allowed to cancel entire factors. Okay, and they have to be attached to everything else with multiplication in order to cancel them out. So let's see, I've got an x minus 2 here and an x minus 2 here. They will cancel. I have an x plus 1 here and an x plus 1 here. They will cancel. So it looks like I've canceled everything that will cancel. On the top, I'm left with a 3 times x plus 4 over x plus 3. Remember, I cannot cancel the x's because they're attached with addition. I cannot cancel the 3. This one's attached with multiplication, but this one is attached with addition, so it cannot be canceled. This is all I can do with this one. Another acceptable answer would be to distribute the 3 on the top, but there is no need to do that. I always tell my students, once you've factored it and canceled what will cancel, just write what's left beside each other. Don't try to multiply them out, because that's another place where you could potentially make a mistake. Here are 2 more problems. One's multiplication, one is division, that require you to factor. So I'm going to step aside, go ahead and pause the video, see if you can get these on your own, and then we'll come back and look at the solutions. Okay, here I factored both of them. I haven't completed the problems yet, but here when I factor, both of those have a 2. I can bring the 2 out, leaving me with d plus 3. Here, I can factor that to d plus 2 times d minus 1. For this one, I flip that upside down, so it's a times. The d plus 3 goes on the bottom, and this can be factored as d plus 2 times d plus 1. And then at this point, I will cancel diagonally anything that will cancel. So the d plus 3 will cancel. The d plus 2 will cancel. And it doesn't look like anything else is the same. So I've got the 2 times d plus 1 over d minus 1. That would be my final answer. For the next one, I've factored everything that will factor here, and x squared came out, leaving me with x plus 3. Here I brought out an x first, and then I factored the trinomial that was left, leaving me with x times x minus 10 times x plus 4. This is difference of squares, x plus 4, x minus 4. This can be factored. It's a trinomial, x minus 4 times x plus 3. And then I will cancel anything that will cancel. So I've got x plus 3, it cancels. The x plus 4 cancels. The x minus 4 cancels. And here, one of the x's will cancel. So that becomes an x instead of an x squared. So on the top, I have an x. On the bottom, I have x minus 10. And that's all I can do. I do want to point out that if you're going through these problems and you end up with factors that all cancel, everything in both of them cancel out, your answer would then be 1. A common mistake I see is students put 0 when everything cancels out. Your confusing multiplication with addition and subtraction when you put 0 down. When everything cancels with multiplication, it becomes a 1. When everything cancels with subtraction, it becomes 0. When everything cancels out because you have the same thing on the top and the bottom, you end up with a 1 for these problems.